Welcome everyone. Today we have our another new episode, and this episode very important for Asia Pacific. Especially we are discussing on advanced manufacturing systems. Uh, Malaysia is a manufacturing hub. China and Vietnam, Indonesia, everyone trying to developing their manufacturing hub. India also trying to developing manufacturing hub after this
Mhm.
COVID-19. So we have our expert panelist. We have our board of advisor for World Talent Economy Forum. Already we discussed that we are launching some very interesting conference and activities. October's we will do works in between Malaysia and United Arab Emirates. Definitely it will be public private partnership related discussions. So more of the government body and the corporate body, those who want to work with World Talent Economy Forums, as well as want this kind of highly intellectual discussions, definitely we are ready to support you. And I'm sure our board of advisors, definitely they're going to support all of the initiatives. So I want to start from Professor Edward,
Mhm.
that how do you want to analyze to this topic, and what are the advanced technology we can integrate it for manufacturing?
Hi. Well, thanks for that, and congratulations on getting your on the recent step of what you've done to the organization. This is great. I'll start off by framing the discussion with 3 points. First of all, of course, is the main point about how the technology we've discussed in so many other episodes can be focused on manufacturing. And I'm sure we're going to hear a lot more about the details. But we've seen this as a process that goes back even decades. For example, in this country, robots have been in factories for many, many decades. I remember one of the first trips I made dealing with regulatory issues. I went to Detroit in the late 1980s, and I went to a General Motors plant, and we saw exactly what they were doing with robotics, how they were trying to integrate quality control into the system. Very, very important. And of course, robotics has grown even more important in the recent years, in part because of the advanced communications, information, and computational power. This is where, of course, you get artificial intelligence more and more integrated into the production process, or the capacity to integrate it into the production process, and especially the quality control process. That's really significant. That was the main problem that companies like GM had, was quality control, and they couldn't compete with the Japanese, for example, in a lot of car manufacturing, because frankly, their cars, just the quality wasn't really there. Artificial intelligence, of course, integrated into the production process allows for that. We've had discussions of 3D printing, which more and more is going to allow customization of production and the like. So that's the first point I want to make. The second point I want to make is, if you're an entrepreneur in the Asian Pacific area, you have to kind of try to project ahead where manufacturing is going to follow the traditional path and where it is not. Because more and more, when we talk about the Internet of Things, when we talk about the fact that we're going to have something like 500 billion sensors of one kind or another forming a skin on this earth by the end of this decade, things that we think of as, well, I need a piece of equipment, you might not need a piece of equipment. For example, software as a service, or for example, when the first Apple computers came out, it was the software that allowed, for example, for accounting, that made the computer, the piece of equipment, valuable. But then what you saw as we developed and as we're developing is more and more services are offline. They don't have to be in a physical thing. So think about any kind of thing that can be manufactured and ask whether there is a substitute for it. The third thing I'll mention is, I want to show you a box here. Now, I'm not sure if you can read this, but I will tell you what it says. It says assembled in China. Assembled in China. And it says other items marked therein. This is a box for my there we go, for my MacBook Air, my MacBook that I'm using right now. Assembled in China is because the manufacturing process, of course, is spread out over many, many countries. The processor, the frame of the machine, et cetera, are made in different places and pulled together in China and assembled in China. A Taiwan company, by the way, is one of the biggest partners in this whole process. And you've seen that whole process of manufacturing being spread out. Again, going back decades and decades, especially, for example, in the Asia Pacific area with apparel, unfortunately, because of America's really stupid, frankly, trade policies that gave everyone quotas. And so they traded quotas around and they did all sorts of stuff like that. What you're going to see, and if you're manufacturing in the Asia Pacific area, you have to keep an eye on what is going to be the political issues going on. You know that we are in a kind of a trade war right now with China, but it's not just a matter of trade, because I'm a free trader. It's a matter of political influence and things like that. So, for example, Apple, which makes most of its computers and iPhones in China, or assembles them in China, I should say, has, for example, contracted out to do manufacturing in Vietnam recently. And we're going to see whether that manufacturing process is spread out more from China to other Asia Pacific countries. So you really have to keep an eye out on the political situation as well, because that is unfortunately going to determine what companies do. You know, one of the big problems, as you know, with COVID was supply chains being disrupted. So you're going to see a lot of thinking ahead, decades ahead, in what should we do with manufacturing in light of the fact that we can have political disruptions, we can have disruptions like COVID and the like. So that's going to be something that goes into the thinking of manufacturers as well.
Mm-hmm. Thank you. Thank you. Dr. Eric, you are from Silicon Valley and you are nurturing many startups. You have a very great experience, but we are discussing on advanced manufacturing. What kind of new technology actually inventing in Silicon Valleys or in your lab?
Well, I have to say, I don't know.
Okay.
I am not involved in manufacturing. I have never been doing things in manufacturing. Most of my work have mostly been in software. So manufacturing software is a lot different than manufacturing hardware. So I have no knowledge specifically about manufacturing of any sort, but I do understand the general arc of humanity. Since Edward was talking about decades, but it's actually true from time immemorial, from the dawn of man. We have been creating technology. Okay, that's breaking off a branch from a tree and sharpening it to making it into a spear, whatever it is. When we were doing that, we figure out how to do it better, faster, and cheaper. And it's always been the case. And going forward, we just figure out what is better, faster, and cheaper. And right now, 3D printing is one way of doing it. Another way is, distributed manufacturing, which is what Edward was talking about. Essentially, that you have that whatever object that you're making is actually assembled from parts that are made all over the world. Okay. Actually, I am working on a project right now that is being manufactured, in China. And I have a partner in China who is helping me doing the manufacturing. And the prototypes have been done using 3D printing because it's faster and cheaper to do a prototype using 3D printing. After the object is prototyped, then we can sort of see whether the size is correct and all these other stuff. And then when we modify it, then we will actually make it with the right material. But at the moment, it's just a prototype made with 3D printing, which is not a usable object. It's just, just getting the shape, the general shape of the thing. And that's what it's done. And that's what it's doing right now. It's just cheaper and it's faster and it's easier to do. 3D printing is much like regular printing that we had 20, 30 years ago. I remember 20, 30 years ago when I was trying to get something printed and I'd go to a print shop and request it doing something. The process was so archaic and so complicated that they needed certain types of formats and this, that, and the other. And the format that I had, they cannot convert. But today, you know, I can send anybody a JPEG, a GIF, the PNG, a PDF, or whatever, and they can convert from one to the other and everything, and they can print it, you know, no problem. And that's what's also going to be happening in the future with 3D printing. Whatever the file format it is for a 3D printing format, that's going to be done, and it's going to be easily convertible from one format to another, and drivers and printers and all that will be all interactive and can work with each other. So that's what I can see in the future. But again, those things are really just for prototyping. You don't use 3D printing for mass manufacturing at the moment. I mean, maybe in the future you can, but I don't see that at the moment, because the material that you need is not always what the material is used for the 3D printing. Okay, that the toner, you know, whatever you want to call the material that you use, the toner for the 3D printing is one type, and it doesn't give you the material that you want for the eventual product that you want. So it's good for prototyping, but not necessarily for mass manufacturing. So.
Thank you. Professor Rob, you are technology analyst.
Yeah.
So what type of technology we can
I also cover 3D printing. So let me correct some stuff. So the 3D printing is that Erica's correct that originally that 3D printing was just for prototyping, but today it's used for short run manufacturing and for customization parts. It is done in volume. The HP industrial printers will print more cheaply than compression plastics. Relatively large number of parts. That process is designed to go into a manufacturing line and print out, but it's done for short run. If you're talking about, a short run means you've got a run of under 1,000 units. A long run where you're talking about hundreds or millions of units, it would only be used if you had high customization. So if you were allowing customers to make a lot of unique selections, then you'd probably use 3D printing over compression plastics, simply because it's cheaper, for one, and number two is because the overall run of the units are highly diverse, and so you need the diversity of 3D printing. It's also used reasonably heavily in areas where you've got craftsmen. I've shown this, I think, before. A number of the stuff that I order from Etsy is 3D printed now, and it looks like it was manufactured. But once again, it goes back to it's ideal for predominantly short run. The long-term plan, though, is to really make it the de facto way of doing manufacturing. And what's amazing with 3D printing is crossed over into metals, moved beyond metal sintering into metals. So you get parts that can be used in equipment that holds up well, and it's been moved to ceramics and can be used in jet engines. Once again, for short run, though, for older jet engines where the parts inventory has dropped out and it's just cheaper to 3D print it than try to bring up the old manufacturing lines and create the parts. But it's moved out of just prototyping. It is still heavily used in prototyping, but it's now used in manufacturing lines and heavily used in the automotive market. But the automotive performance parts are built today using 3D printing. Now, having said that, moving off into the future of manufacturing, one thing since I do spend a lot of time, or did spend a lot of time in manufacturing and used to audit large plants, the best practices are, in fact, we can compare Tesla versus Tata in terms of manufacturing approaches. Both have moved to heavy robotics in terms of manufacturing. What Tesla did wrong and Tata did right is Tata brought in experts, a lot of them out of Mercedes, that understood how to do manufacturing and maintain quality, where Tesla was largely built with technology experts, but not experts in manufacturing. And so when both employed a high degree or robotics across their plants, the Tata plants tended to be higher quality than the Tesla. In fact, Tesla's one major constant complaint is the low quality their factories are turning out. It's not because the equipment can't do high quality. It's because they've got inexperienced people doing manufacturing, and the mistakes that they're making are avoidable if people know what the heck to look for. Now, it's funny because the last factory I reviewed, I went through was a Mercedes factory, and I wasn't at all impressed with the level of automation that they had and the amount of defects that the cars were initially being pulled off the line for. But it turned out the issue was a labor problem, because in Germany, they've got requirements for labor retention. And so their ability to automate is highly limited by the regulatory environment they operate in. And so they had people doing jobs that could be better done with today's robots. I mean, like one guy, they were so excited about this automation. A computer would show a light on a box, the guy would pick the part out of the box, and it would show a light on another box, and then the guy would have to fit the part in the other box, and the box was supposed to position the part so it could be properly assembled. And so you'd see this guy, it was like he was trying to assemble a puzzle, because they're going for different cars, so it's never the same. And he's trying to figure out, how does this part fit in this? I mean, he's got an audience while he's going, well, maybe no, it kind of goes this way. No, maybe it goes in like, oh my God, this guy's building cars. So just a bad implementation, but it had an awful lot to do with the fact that the German government makes it very hard for you to get rid of people when you're automating, and putting people in an automation process doing jobs that are being better done by robots is pretty bad. One thing that's interesting that just happened, I think it was yesterday, was Elon Musk announced a new run that they're going to release robots themselves next year. Now, be aware that Musk has a habit of overpromising and under-delivering with regard to timelines. Their cars have a tendency of showing up about a year later than they're announced they're going to show up. But he does get them done, and I think SpaceX kind of showcases he can do some stuff that a lot of people thought were impossible. So I wouldn't put this past him, but he announced a robot, humanoid robot, a big step up from Baxter, which was the last manufacturing robot that we had that was designed to be a universal replacement for people. And the interesting thing about Baxter wasn't that it didn't do the job, but just that the jobs they were trying to have Baxter do was actually more cheaply done by people than by Baxter, so they couldn't make the economic argument. So a $20,000 robot, which doesn't sound all that expensive to me, couldn't compete with minimum wage, which probably speaks a lot more about minimum wage than it does about robotics. But Baxter failed. The robot that Musk was showing was a humanoid robot that was fully articulated, that could be used in someone's home to help them around the house, could do things like changing tires and do a variety of tasks that were physically intensive but didn't require a lot of intelligence. Like, for instance, tasks that disabled people are currently using trained monkeys for, that kind of thing this robot could do. And so it could be a huge boon to people that are disabled, that are living at home and need a lot of help. Could also be a huge boon for places where there are labor shortages and they need people to do physical, repetitive labor with tools that are designed for people. So it's going to be interesting to see how it flows through. Looking at the overall design, I question whether the markets that he's targeting this for are going to be able to afford the product that he is building. But it is an interesting path. But the thing I really want to point out, though, is if you're going to be using these advanced technologies in manufacturing, first you really have to understand your regulatory environment, which is what Germany showcased. And number two, you need to have people that are expert, not just at the technology, you need those too, but expert at the processes that you're automating, so you don't make the mistakes that Tesla did, and so the product quality holds and the end result is what you intend. The robots can make things, and automation can make things far faster, but that also means that mistakes that are put into the process multiply far quicker as well. My last example was on an IBM automated manufacturing line, one of the first ones we put in place. We had 100% failure rate coming up the back end because nobody thought through the fact that you needed to do a quality check, a comprehensive quality check, several times on the line. And because we weren't doing that, one process was breaking what prior processes were doing, and that was resulting in 100% failure out the back. And it was cheaper to discard the equipment than it was to repair it, which I'm still kind of shaking my head at, because when you're getting 100% failure rate and you're producing 10,000 of these damn things a month, and all of them are going into landfill, you probably should just stop the process. And this went on for a while before we did and brought in a couple of analysts to look at the line and fix it. So final comment, not only do you need experience, but if you've got a problem, stop the line. Do not restart the line until you've resolved the problem. Otherwise, you're going to have a whole heck of a lot of avoidable waste. And that's it for me, assuming we didn't lose Sharif. Sharif looks frozen at the moment.
Maybe we should go to, Dan, I think you're next.
We're in self-captaining mode here.
That's right.
The crew's taking over the ship.
Hayekian spontaneous order. Everyone read Hayek.
Yeah, right. Complex dynamic systems are disrupting everything.
We need to send Sharif Starlink as well.
That's right.
Yeah. Let's do it. Let's get a Kickstarter going for everyone.
Right.
Everyone
maybe
maybe
Elon will donate it. I mean, come on.
Yeah. We talk about him so much. He should comp us on that, right?
Your turn.
Okay. Funny you mentioned Elon Musk. A lot of controversial guy. A lot of people don't like him. I like him. He's done some
building
amazing.
Rockets, going to go to Mars. Come on.
Yeah. How many? Yeah. Send a Starman in a car to Mars, and then you can criticize. Okay. But I love his design philosophy, which is basically every design is wrong. It's just a matter of how wrong. Like his other sayings, like the best part is no part. The best process is no part. If the schedule is long, it's wrong. If it's tight, it's right. Anyway, I think he's got a future in rap music, maybe. There. But, and one thing he did with his Tesla car Gigapress is he totally disrupted, how he says, I want to make cars like we make toy cars. So he actually, built this press that is the largest metal press, it's ever been built. I think there's only like 2 or 3 of them in the world. Well, I think there's a half a dozen, but anyway, he's able to build the rear chassis, the crash rails in one, massive injection flow. It's saving like, I think almost 80 plus parts of steps, so he gets the details that had to be worked out to make this Gigapress work. I mean, the alloy has like, I don't know, 20 different elements, fine tuned down to like 3 decimal places of, it's a perfect alloy to do what needs to be done to create these parts. But by God, that works. And okay, so that's one hero of mine. Another hero of mine is Marcin Jakubowski from Open Source Ecology, who has something called the Global Village Construction Set. And basically, these are machines that you can build for the price of scrap metal and labor at about half the cost or less than a typical retail version of the machine. And I'll just there's like 50 basic machines that enable a raw village to get started. Some of the things are 3D printer, 3D scanner, aluminum extractor from clay, backhoe, bakery oven, baler, bioplastic extruder, bulldozers, compressed earth block press, which I think that's a great one, actually. The compressed earth block lets you take materials on site. Like you can take the dirt that's where you want to build something, sift out the right fraction of clay, add a little bit of binder material, compress it with 3,000 pounds of force, which you could actually do with just a lever-operated lever and cam. There's actually a design from, I think, VITA, the volunteers, and it's a UN organization. They have a version that works just on human energy. But the great thing about these compressed earth blocks, there's no supply chain. You're building it with the on-site materials, and the finished block is fireproof, insect-proof, high R value. So, really getting compressed earth block presses out there to all parts of the world where people are shelter challenged, let's say. that can be a huge part. Anyway, the right to repair is a big controversy right now because actually Marcin had a PhD in nuclear physics, and he wanted to get into farming. He bought a tractor. The tractor broke. He tried to fix it, and then he was broke. He says in his TED talk. So, and then nowadays, if you buy a tractor from John Deere, you're not allowed to fix it yourself. You have to have the John Deere expert come out at like $250 an hour and replace a little proprietary part on there. And this has really spawned what's called the right to repair movement. Mm-hmm. And this sort of goes along with the philosophy of open source. You build these things from freely available plans that you can share and modify, and sharing with your neighbors should not be a crime. But this is, I think, the future of manufacturing is short supply chains. Sharing locally, sourcing your feedstocks locally. Bamboo, for example. There's a company that will pay you like $70,000 an acre to grow bamboo, which is an amazingly versatile building resource. Talking about 3D printing feedstocks, the little caps on your 2-liter pop bottles, those are practically the perfect mix, ready to be made into 3D printing filament. So, and those are available basically, for the cost of finding them, I guess. So we can do a lot to upgrade our current manufacturing situation, and it can be a lot of fun in the process. I'm going to have a booth at the street fair in October 17th here in Thousand Oaks, and I'm working with the local makerspace, the Canoe Valley Makerspace, and we thought a great project is going to be to print out a 3D printed scale model of our watershed, and we'll be able to see the city of Thousand Oaks and where it sits in the greater watershed, and print it out in little 6x6 squares and have school kids paint them, do the detail work. So I think that's going to be a really, really cool project for the street fair. And I would encourage every community to do something like this. And then if it's made thin enough, we can actually integrate lights in there, LED lights, and you can display different versions of information with lighting, or just video projection. Maybe I'll figure out which is best. But just being able to visualize, how water flows, in your watershed is a hugely important thing, because this is a water planet, and a lot of the things we do compromise the water safety and health. So becoming water conscious and becoming a better manufacturing steward, that can all happen at the local level. And I'm done for now. Thanks for letting me rant on about that stuff.
Mm-hmm. Thank you. We have our new guest, Mr. Shankar. He is our partner from India, even our ambassador for World Talent Economy Forum, and our new guest, Mr.
Xavier Hurtado.
Mr. Shankar.
He's my guest. He's from United States.
Okay.
He's my
Okay.
guest.
Thank you.
And he's
Excellent.
also an expert on futuristic manufacturing and factories of the future, because he advises some of the biggest groups in OEMs. So I thought I'll invite him and see what synergy could be built. Thank you, Mr. Hurtado, for being
excellent.
here.
Thank you. So, can you hear me? Our new guest, Mr. Xavier. I'm sorry. Frozen. Yes, that's why I'm a little bit of confused. Anyway, Mr. Shaw.
I don't know if my connection. Can you hear me?
Barely. You're breaking up. And it doesn't look like your mouth is moving.
Mm-hmm. No problem, Mr. Shankar. You can continue. We can learn some part of India and how your organization's working with the manufacturing industry in India.
Hello.
Yes.
So move a little bit. His eyes move.
Yes. Mr. Adam.
Right. Do you want me to talk for a bit?
My connection's not good today.
If we can hear you on and off, Mr. Hurtado.
Yeah, I wonder if you can hear me now.
Yeah, kind of.
Yes, I request like before the session start, at least 5 minutes ago, if any of the speaker joins, maybe we can solve the technical problem. Anyway, Mr. Adam,
Oh,
please
okay.
continue. We are discussing
Yeah, sure.
on manufacturing things.
I
Yeah.
believe my
Thank you.
connection's way too slow.
Okay.
So,
Yeah,
yeah,
let's see if you can
very
hear me now.
recently we were
And I'm glad.
put,
Yes, Mr. Javier, I will give you chance after Mr. Adam. Just give him 2
yeah,
minutes. After that, I will come to you, Mr. Adam. Yeah.
okay, cool. Thank you. So yeah, very recently we were talking about smart cities and 3D printers, weren't we, and related subtopics across several episodes previously. So with smart cities will come smart factories, smart industrial quarters, smart industrial estates. So I think 3D printing and nanotechnology and the overlaps between the two will be a kind of deus ex machina that will revolutionize almost everything, just like computers, computing. Digital technologies and communications and portable smart devices have revolutionized nearly everything that humans do, produce, trade in, innovate. So the next ubiquitous revolution will be nanotechnology and 3D printing, I say with some confidence. Maybe portable 3D printing if we look further into the future. So I think this intergenerational shrinking of technology that we first saw with computers going from something filling entire rooms into our hands now, we may well see with factories, assembly, industry, where we may well see in our lifetime microfactories that can fit on a desktop, yet can produce something that required entire estates of factories and warehouses. And then these desktop 3D printers or desktop factories, microfactories, nanofactories, may be able to produce a lot more than traditional mega-sized industrial premises. And the same development could happen with power stations and power plants and such. These kinds of emerging technologies will be a godsend in medicine as well, and sufficiently developed nanotech and 3D printing that is engineered to be versatile and quick will, I can imagine, save more lives than we ever thought possible before. And like I said, these technologies are like a godlike deus ex machina that has universal applicability or near universal, just like how we use computers universally, no matter what field you're working in. And patients won't need to wait for suitable donors if we could just scan their bodies and 3D print one according to their body and their makeup. And nothing that needs fixing will ever be too hard or too awkward to reach with a fleet of nano machines and a kind of changeling cloud formation or a configuration reminiscent of Starling clouds doing their ballet in the sky. So that will apply whether the damage is in something mechanical or organic in a medical or healthcare situation. But there's no stopping technological innovation and the universalization of technology to something that can't be slowed down when interested parties are funneling millions and billions, trillions into these developments. So we need to figure out how to live in a world enabled nanotechnologically and one that is industrialized with powerful 3D printing capabilities without people falling through the cracks into despondency that is a risk of automation. We don't want millions or billions of people feeling useless and that their lives are meaningless. Maybe not completely meaningless, but any meaninglessness is bad for a person's well-being and soul, I think. Thank you.
Thank you. Mr. Javier, can you hear me? Can you hear me?
Yes, I can hear you. I shut down my camera to see if the bandwidth is better. Can you hear me now?
Yes, yes. Thank you. Thank you.
No, thanks to you and thanks, Mr. Damodaran, for the invite. And glad to meet all of you initially through here. As Mr. Damon said, we work with a lot of manufacturing companies, automotive, aerospace, medical devices, oil and gas, and the US, and mostly with the expansion projects to different countries. So, just to share, it's going to be very interesting. We're just talking with Mr. Damodaran to see how we're going to need to map out different manufacturing capabilities. Right now, for example, most automotive OEMs are very concerned in regards to the manufacturing of electrical vehicles. And their concern is that the manufacturing base that they have right now, it's very used to the old school model, so they need to reshape like working with light metals and working with this is like with better efficiency vehicles. And this applies also to aircraft. So we were just discussing about mapping out different, on the one hand, manufacturing capabilities, including complexity of manufacturing. When we classify in North America or in Europe the complexity of parts that they can be manufactured, we're talking about 5 to 7 levels. And usually what happens in emerging communities is that we can manufacture levels 1 to 3, but not high level complex parts. And that's what's going to be one of the challenges we're going to be facing, or at least one of the fears. And that doesn't mean that the talent's not out there, but the knowledge that they had, especially in North America, they kept it for themselves for a long time. And this decade, the expectation is that 50 million baby boomers will retire, putting in some sort of danger or threat the losing of know-how. There's a lot of blueprints still in 2D, and most of the manufacturing knowledge happens to be inside the minds of the technicians and engineers. So on the one hand, it's a great challenge that we have ahead of us. I say it's a great challenge dash responsibility and privilege that we have if we know how to convey that hidden knowledge into the next generation. And right now, there's going to be a very good opportunity to actually even acquire or partner with US and European companies and transfer them in a phased transition to Southeast Asia. Southeast Asia turned just into the largest economic bloc, the largest free trade agreement bloc. So it's going to be a great opportunity. And the concern of the large OEMs, aerospace, and automotive mainly, it's how can they transfer the best of what they have of manufacturing knowledge into Southeast Asia, and then how do they turn it into what should be the next manufacturing model. And by the next manufacturing model, obviously we have the 3D printing that I was listening when I just joined the link. 3D printing is going to take over a lot of areas, and right now we are like not ready for it. So it's a great challenge. We need to explore lighter and different materials. 3D printing, there's going to be a lot of skill talent required. So the challenge for us right now, especially for Southeast Asia, would be like, how can we map out, number one, the current capabilities that we have, and these capabilities, not only by the name, not only like CNC machining or sheet metal or plastic injection molding, but also in depth as far as talking to the complexity of parts that they can manufacture. And if they have also embedded engineering and design, that means that they could do reverse engineering, because there's going to be a lot of parts that are very old blueprints or no blueprints at all. So I just wanted to share that it's going to be a great, once again, challenge and opportunity and privilege to transfer and transition the manufacturing muscle that we had in North America and Europe, because they're aging. So it's going to be a great opportunity for this decade, I believe.
Thank you. This is really great discussion, Mr. Shankar. I'd love to learn more about India, what's going on in South Asia. Especially, I can remember a few months ago, I joined Honorable Prime Minister conference with the Tata groups, and they are taking new initiative, especially the COVID. After the COVID, they are taking some initiative of uplifting their society, and India also trying to develop a blueprint, especially for manufacturing and this kind of things. So what you are observing in South Asia after the COVID, what is the impact in manufacturing hub? You are also running Chamber of Commerce. What the
Yeah.
situation right now, especially the entrepreneurial present situation?
India is really, really opening up, and the government is getting aligned to actually receive international companies to set up shop. And in that direction, all these companies and all these factories that we're talking about, like the automotive, the aerospace, the light engineering, the medical devices, energy sector, we are at a stage and at an opportunity stage where I get a lot of companies approaching to say that these are Chinese companies that is getting back, and we are put not Chinese companies but U.S. companies that is pulling out of China, and they're looking for opportunities to set up shop in India. So here is where my connection with Mr. Hurtado is very strategic, because Mr. Hurtado has been working in OEMs in North America and advising them of global supply chains, how tier one and tier two manufacturers can align. And there's a lot of possibilities, because what is happening is the quality check, the logistics, the pricing, and many things have been happening. But today the game has changed. All of that needs to be incorporated in India and match those standards in the global supply chain. And that is what Mr. Hurtado is saying, that when we have talent in India, some of the companies will come to India, but we need to match the talent, which is the requirement of those companies. And matching the talent would mean all this transition stuff into EV cars and EV automobiles and the design side of it, all of that. And he's suggesting that probably the 3D is a big revolution where the design needs to happen in South Asia. So this designing and all of that can come to India in a big way, which means university tie-ups can happen to teach students and to teach technical students how to design these new components. And the manufacturing can have in-shore capabilities. Earlier, we would do logistics and all that planning to actually align supply chains. Now, manufacturing will happen right there at your home city or home country, but design will come from anywhere in the world. So the transition again into that. So this is where we think the talent economy can play a big role in helping students and technology students. And I think, Mr. Hurtado, if I'm right, the OEMs are willing to employ them once they qualify, right?
Actually, right now, just as you're saying, that there's going to be, well, there is a gap of talent right now. If we go back to January 2020, just in the US alone, we were missing more than 500,000 technicians and engineers. And that was before we see what's coming. And what's coming is that 53% of the labor force, technicians and engineers in the shop floors in North America, are 55 years old or above, which means this decade they're going to retire. So the gap that we had of 500,000 in 2020, in January 2020, it's nothing compared to what's coming. So the need for talent, especially of specialized talent from Southeast Asia, is going to be a very good opportunity and challenge. And that's why North American OEMs are very worried about talent. And right now, what's going to be happening is that if we go back 20 years ago, that they decided to relocate operations because of cost. It was looking for low-cost countries, or best-cost countries, as they call them. If they want to survive for the next decade, they need to relocate to wherever there is young talent. Because in North America, there's none. I mean, we helped a company from New York relocate to Mexico, and it was very interesting because when we started doing the recruitment in Mexico, there was a line of more than 300 people trying to get a job. And obviously, the VP of operations, he was taking pictures because he said, if I try to do the same thing in New York, in upstate New York, we don't find the talent. Best case, we're going to find 15 applicants, out of which we're going to hire 3 of them. And perhaps after the first quarter, we're just going to keep 1. So that challenge has been happening for the past decade, but this decade is going to increase. So that's why it's going to be very important to actually map, detect this eager talent that you have in Southeast Asia, and most especially try to develop them. One of the exercises we did, there's a lot of communities that there's a misalignment between the industry and the academy. Usually the academy is training them for things that are not going to be used in the industry. And then they create this special training courses or even undergraduate programs that serve no purpose for the industry. So what we did, this was with some OEMs and tiers one. We mapped their organic growth for the next 10 years. This was in 2013. So we said, let's map your organic growth for the next 10 years, including quantity and quality of technicians and engineers. And that meant every skill set that they would require. And also the right number so that they wouldn't compete for the same talent. Otherwise, turnover would be high. And we were able to bring also International Youth Foundation. And what they did, they invested $1 million to connect the academy with the needs of the industry. And this $1 million was allocated to actually train teachers and to create a train-the-trainer program. So they took these teachers to operations in the US to actually learn from the specific machines that the OEMs needed the talent to be knowledgeable with. And then they had to get back to these communities and transfer that knowledge. And later on, they created this software, which is actually an online database where they monitor all the graduates from those programs. Right now, I believe it's the 8th class or generation that they create. And they have a very good follow-up of graduates. So they avoided turnover on the one hand, but then on the other one, they reduced the complaints of the industry where they were saying that there was this misalignment. So if we're able to replicate this in Asia right now, in the different regions, what are the universities and technical schools that are with eager talent and this type of talent? If we could map it out and align it with the skills that the industry will require, it's going to be a very easy game to relocate those value chains entirely. It's not only the OEM, but also the OEM. Whenever we relocate an OEM, they bring their tiers one, especially in the automotive industry. They need their tiers one to be in less than 50 kilometers around. And tiers two, they need to be in less than a 200 radius of kilometers. So what this means is if we are going to relocate value chains, it'd be good to map which regions in Southeast Asia we should take them to, what type of supply base do we have, and what type of skill set we would be allocating, and perhaps even to understand the regional callings. We could say one region, let's specialize on engines, one region, let's specialize on major structures, another one on interiors, and then that way they don't compete against each other. So those are things that we could be doing, and that represents a very good opportunity for the next 10 years, I believe.
Thank you, Mr. Hartadu and Mr. Shankar, for your excellent contribution. Actually, World Talent Economy Forums, we are working on that area. Even we have excellent expert from around the world. We already declared our boards, and all of them are highly experienced. Thank you, Mr. Kevin, join with us. And we are trying to solve this problem. Actually, the long time from the industry and academy, they have the gap. And yes, talent is everywhere, but we need to connect the talents. And major things, it's my understanding that after the COVID, many countries, they need to take their own preparation, because globalizations and the global business model and supply chain, especially the supply chain model, will be changed. So in that situation, maybe we have to restructure many procedures. We have to think differently about human resource developments. So we are aligned with this things, and we are working with the developing nations, and hopefully with all of our contribution we can add some value. We have our another new guest, Mr. Kevin. So we are discussing on advanced manufacturing. So how do you want to contribute for today's discussions? Then I will go for the concluding remarks. Yes.
Well, thank you.
So this is what I just want to. Sorry. No, I just want one line.
Yes, Mr. Shankar.
Yeah,
Mr.
I wanted to
Shankar.
add that Mr. Hurtado is working on a curriculum for technology universities in Southeast Asia, keeping in mind what the OEMs of US is required. So I'm working in conjunction to put that curriculum together with Mr. Hurtado and take it forward. And I would come back and see how we can integrate the universities and technical universities, how all of that can come together to create a great ecosystem.
Excellent. Yes. Thank you. Sorry, Mr. Kevin. Yes, please.
Well, one thing I'm working on that is related to COVID, I work in financial inclusion, economic justice, those sorts of things. And I'm looking at local solutions with local ownership, sometimes collective ownership, sometimes ownership of assets by communities that aren't used to owning assets. And so a lot of that is distributed, but some of that needs to be centralized. And so we're looking at things that can be centralized, specifically pooled reserves, loan loss reserves, the first loss reserves that are catalytic, that can cause a lot of things to happen. And we're also looking at virtual back office for the micro entrepreneurs that we invest in, including bookkeeping, virtual assistants, and HR things, because we've got some funds that are helping sole proprietors become job creators. In the U.S., 90% of Black-owned businesses are sole proprietors. So we've got a fund that's working on that. And so there's some things within the decentralization that should be decentralized, that should be centralized, like a virtual back office, like loss reserves. But then I think we need to be localizing and decentralizing asset ownership and taking it away from the centralized Wall Street hubs.
Thank you. I directly want to go for the concluding remarks for today. Professor Edward, what do you want to add?
Well, first of all, yep, okay, I'm on. Yeah, first of all, I'd like to contact Mr. Hurtado and Mr. Shankar offline, because I'm working in exactly this area in terms of public policy here in the United States. And so there's a lot of things I'd like to consult with you on, because I'm doing exactly this work. And this last part of the discussion, I think, has been absolutely critical. At the beginning of this talk, and a couple of you weren't on, I mentioned the fact that for decades there's been this huge disconnect between the schooling system here, certainly here in the United States, and the need of entrepreneurs and enterprises and so forth for talent. It's really incredibly bad in this country. If you take a look at, I won't go into it because we've had other discussions about this, but to me, this is absolutely crucial, both moving ahead in terms of the needs for future manufacturing and every other area of technology, especially medical technology, by the way, which is one of my interests. And so we're going to need a synergy between the manufacturing revolution, the technological revolution, and an education revolution. This is where Sharif's idea of working with businesses and industries and education to train talent is absolutely crucial. I know that some of the problems in the past with India, for example, was quality control, and in a lot of cases, companies wanting to locate over there could not get either quality control, or the local government officials would get in the way, and that would prevent them from doing their job. But things are changing right now. I think that there's incredible opportunities in the Asian Pacific area, especially because, as has been commented on, a lot of companies now want to diversify. They don't want to have everything in China for both political reasons and because of supply chain issues with COVID and possible future problems. But talent is all important, and so I want to really emphasize the need to have the talent match the needs of the market. And I'll have to jump off in a few minutes, but I want to contact some of you offline, because this has been an incredibly important discussion.
Thank you. Thank you. Dr. Eric.
Yeah. My concluding remarks is basically that manufacturing is sort of the interface between humans and the final product, right? The product that you're making. And the goal of manufacturing, or building the manufacturing infrastructure, is to make it simpler and simpler so that the humans that are running the manufacturing devices can do it. Okay, you want to make the user interface and the user experience and all that easier for people to use, so that you can, push a button and get that thing working. Because if it's complicated, then there's a lot of study and a lot of knowledge needed to be able to run it. And when that happens, then you have fewer people who are capable of doing it. But when you simplify it, and you make it easier to use, then you have more people using it and more people doing it. And the advantage of all that, not only is it that you can get lower paying people to do it, is that the smarter people will figure out how to use it in a different way that is completely unexpected. And those are the people that will branch off with this technology, like robotics or 3D printing, and do something crazy. And it's a completely new dimension, a completely new avenue for people to go into. And that is where it branches out. And then a whole new field comes in. This is the blue ocean that people talk about, that when you move into this new space, then they're doing something that's completely unexpected of them. And then you get some great ideas and you get some great products and great designs and all that. And that's how creativity flourishes, and this is how wealth and wealth generation is created. Because when you create something literally out of nothing, right, from using the creativity of the brain and just trial and error in some cases, then you get something completely new, and that is where the creativity comes in. So that's what the goal is to reduce the complexity of the tools. And when you reduce the complexity, then you get better the products that you want to intended to make, and you also get new things that you never ever thought of.
Thank you, Professor Rob.
Okay, so that's a lot of stuff to parse here. Dr. Eric, we just talked about making equipment simpler so that people can use it. It's funny because that's kind of been the goal of technology pretty much since its start. The difficulty, of course, we've had is we train people to work on machines. The latest breakthroughs with regard to conversational AI are about creating systems that actually alter themselves to work better with people, which kind of is the way the industry is now working to address this problem. The shortage of workers is very real. It's across the entire value chain. I think we're short something like 250,000 long haul drivers here in the U.S. as well, and that's one of the things that is driving autonomous trucks, is to solve those delivery problems. And of course, right now, the entire industry is brought to its knees as a result of a microprocessor shortage. And Toyota just shut down this week because they can't get enough parts to finish their cars. And there are fields of GMs and Fords that are unfinished now that can't be sold because of that same problem. And being able to understand the value chain and assuring logistics now has become a critical problem. Don talked about the press that Elon Musk used. It's kind of funny because that's often used as an example of Musk not really acknowledging that he's not right in all things. The method of manufacturing that Tesla uses makes the cars almost impossible to repair, even after minor injuries to the rear quarters of the car. And you'll find a lot of Teslas are taken off the road as a result of a minor accident. As a result, it's more expensive to repair them than it is just to replace them as a result of that very manufacturing method. But they're still doing it. And Musk also had that nasty habit of calling his level 2+ autonomous system autopilot, which has gotten a whole crap load of people killed. And now has Tesla under investigation because a whole bunch of those cars have run into support vehicles, police cars, ambulances, and the rest, and not only killed the drivers and the Teslas, but killed the people working in those cars, simply because that Tesla has overpromised and underdelivered on the technology. They're not even the best in self-driving right now. GM is. When we talk about manufacturing, the interesting change right now is the use of simulation and digital twins. That's really the breakthrough that BMW, for instance, is showcasing pretty heavily this last year, is the ability to fully emulate a manufacturing site in simulation before building or modifying it. And they've got one of the most extensive uses of robots for moving parts around manufacturing floors as a result. And they did all their testing and simulation, so no workers are actually hurt in the process. And one of the big problems we currently have with highly automated manufacturing areas that we don't talk about a lot is the number of injuries that are occurring because people and machines don't mix well unless you really redesign the manufacturing floor to assure their safety. People do stupid things, and they will often walk into areas that where robots are working. Current generation robots will stop if they sense a human in their area and do have the capability of stopping if they hit something that's in an area where something shouldn't exist. But they're still in the minority, and so you have situations where you're mixing people and robots where people are still being hurt, and that's why it's so important now to move to simulation and digital twins, so a lot of the testing can be done in simulation before the factory is built. And of course, if anybody's built anything, you know that the more planning you do at the front end, the cheaper the assembly process is going to be, because it's making changes after the construction process begins that makes these things so very expensive to do. And so the more that you can do in digital simulation, the better off you're going to be. And GM's latest electric vehicles, the Cadillac LaRocque is the first one off the line that uses this, but it was created largely through simulation as opposed to the more traditional method of modeling, building clay models and physical representations. They use simulation to get the car to market more quickly. And their next line of vehicles, including the new Hummer, are all being built in that way, and it's allowing them to get time to market. And on spec, for the money, the coming LaRocque actually outranks the Tesla, $20,000 cheaper, higher quality level, higher level of luxury, and similar performance for 20 grand less. We'll see if they sustain it when the car shows up next year, but it is showing great promise in terms of being able to build a high quality vehicle at low cost, largely because you resolve the problems in simulation and not after the first run of the car is manufactured, because clay models don't tell you how those parts go together. They just tell you how it's going to look. So we're making some broad improvements in terms of human machine interface and the use of computers to simulate what you're going to do before you do it, which is saving lives and reducing substantially the cost of building out lines, because the mistakes are done digitally and not physically.
Mm-hmm. Thank you, Professor Rob. Mr. Dan, what's your concluding remarks?
Wow, that's a great deconstruction of the problems that fail with the Gigapress and Tesla. That's very, very insightful. Yeah, I mean, I think you always need to ask yourself, what problem am I trying to solve? Because a lot of people take off and they go, "Oh, this sounds great. Let's try this," and they don't take a whole systems approach to problem solving. Start with that blank sheet of paper, and and then the blue ocean approach is important too. Like, don't try and start an enterprise in a crowded ocean. Look for the blue ocean where you can have a better chance of not upsetting existing entrenched things. Like, you wouldn't go to Las Vegas and try and open a casino without being well connected in the town already. Is one maybe kind of example. I think we're in a kind of crisis moment in civilization and in the biosphere health, and we need to take a whole systems approach to saving the biosphere. And one thing I am championing is a kind of moonshot project to create a global permaculture corridor that interconnects the world with human rights, freedom of movement, and permaculture is kind of a food forest, permanent agriculture approach. It uses the triple bottom line of people, planet, profits. It has ethics that are centered around biomimicry and the way nature already behaves. So we can use all the cooperative resources of the planet, and especially geographic information systems, which I think applying the why of where, to our problems is really huge. I think that's actually going to be as important as the steam engine was to the first industrial revolution. So great topic and great panelists, and I guess we're getting close to overtime, so I'll yield the floor there.
Thank
Thanks.
you. Thank you. Mr. Shankar, what's your concluding remarks today?
Thank you. I've been exposed to some wonderful ideas tonight, and I think there is great opportunity in collaboration with the human side and the machine side, and looking at all these 17 SDGs to make sure that we have earlier messed it all up in the interest of a small group of people or places. Now it's time for us to integrate everything, and that's what I take home tonight. And the simulations bit is fantastic, because simulation is a thing that is a prelude. Without making costly expenses, we can test everything and come to the terms where exactly the prototype needs to be. So I think these are things that needs to be incorporated. And I also felt that geographically, if a nation is progressing, there's a time when the dip happens and looks like Southeast Asia is the place that's going to take it over. But we as a human race doesn't need to look at it that way. One gains, everybody gains. That's my closing remark.
Thank you. Thank you. Mr. Adam, what's your concluding remarks?
Thank you, Sharif. Furthermore to what I was saying before, the universal applicabilities of nanotech and 3D printing technology will make these kinds of innovations useful for tackling other areas like poverty, tackling pollution and pollution damage, disaster zones, and even though I said technology backed by powerful and influential interested parties, still not unknown for powerful technologies to be kept secret, hidden, suppressed by, again, wealthy parties who use their influence in bad faith because they built their wealth on industries that would become obsolete by nanotech or whichever. The hemp industry is a historical example. And even with the internet, there is still plenty of secret knowledge and hidden knowledge and ways of doing things, like Mr. Xavier said. And unfortunately, the utopian Wild West information wants to be free atmosphere of the internet, as I remember it before 2016 or 2017 thereabouts, is over for now, but hopefully it will return sometime. But for now, censorship has been ramped right up across social media and search engines. Even DuckDuckGo has been affected. So this poses a bit of a roadblock to the aforementioned universal applicability of nanotech and 3D printing. If certain blueprints, plans, designs, outlines, maps, structures, architectures that could improve people's quality of life and happiness massively are censored or suppressed because powerful conglomerates build a lot of their wealth from people being kept on a hamster wheel of dissatisfaction. The hedonic treadmill is very lucrative, unfortunately. And it is known that these kinds of aforementioned conglomerates don't really like large populations of retirees because they're no longer producing as much as they did when they were in the workplace. But if these emerging technologies can help those in poverty and help to bridge the gaps between these different classes, castes, social strata, then it could also enrich the lives of retirees, because some characters and some personality types find their life meaning during retirement after official employment. So hopefully these technologies of production and manufacturing and assembly will revolutionize the creative industries and spheres of human activity, so that these retirees over 60s or older, if people are living longer, will not feel left behind by an exponentially rocketing high-tech society. Thank you, Sharif.
Thank you. Thank you. Mr. Hartaru, what's your concluding remarks? Actually, I cannot see you.
Well, thank you. I'm gonna have to be very fast because I need to jump into another meeting. But I'm glad it's different perspectives that we have, and if we put an avenue of merging all these insights together, I believe we have once again a great responsibility, challenge, and privilege to build what's gonna come for the next decade. And potentially there's going to be a lot of manufacturing capabilities that are going to be left behind, and they're going to be taken over with a new wave, I'm going to say. So we have once again the challenge and the privilege to make it happen. Thank you so much for the invitation, and I'll coordinate with Mr. Shankar to potentially share next steps.
Thank you. Thank you. This is a really good discussion. Mr. Kevin, what's your concluding remarks? Unmute, please.
Sorry. Yeah, when you look at big manufacturing, you have, intriguing choke points that might inhibit its future growth, like the scarcity of heavy metals inside your phone, things like that. A book, The Atlas of AI, looks at all the different kinds of materials that it takes to build artificial intelligence, and where that scarcity is. And I think there's some intrinsic things that won't work in the future with long, brittle supply chains and some big manufacturer. So, some things that are happening, like there is and it seems to be really working, a 3D printing of a house using earth on local distributed manufacturing. Those sorts of things that can work with local, resilient, distributed supply chains, and figuring out, those materials that you can't source locally. I think you're going to have to do a whole different topology of sourcing as you go forward, with the Chinese trying to control heavy metals that you need in your phone and other things like that. So I think it's going to have to look a lot different, and the supply chains are going to have to look a lot different, and the supply chains are going to have to look a lot different in response to the IPCC, the climate change report. We can't continue to do this kind of global economy where things need to be shipped over such long distances. I think shipping containers are an incredible drain on the planet. So I think we have to. Everything about manufacturing has to be read with a lens of what materials that go into it are not going to be available through monopolies of different countries or things, and what's the impact of climate change. And I think that's a really interesting rethinking. The most holistic book around that in one area is the Atlas of AI, just because she looked at everything that's inside, the dual core processors and everything that it takes to get those things to somewhere. I think we're going to have to do a level of distance, climate, material sourcing analysis when we do manufacturing, and do stuff that travels less and is built more locally.
Mm-hmm. Thank you everyone. This is really, really great session. The audience, those who are observing our show, please share our content with your government, policymakers, with corporation, as well as university, World Talent Economy forums. We are trying to develop a better ecosystem, a knowledge-based ecosystem, and definitely we are focusing on talent economy, and we need more support, more collaboration, and we have our excellent team member like Professor Rob, Mr. Dan, Mr. Shankar, Mr. Adam, Dr. Eric, even Mr. Kelvins and Mr. Hartudu. They also can support World Talent Economy Forum initiative, and this is a teamwork. And definitely, with your experience, we want to solve many of the local problems. So thank you, everyone. This is really great discussions,
Thank
and
you,
I want to give thanks everyone for your excellent contributions for World Talent Economy Forum. Bye bye and take care.
Thank you.
Thank you. Bye.